Hey everyone! In today's video, I want to tell you about an incredibly exciting new AI model called LongNet. LongNet represents a massive breakthrough in natural language processing. This new model was introduced in a paper from Microsoft researchers called LongNet, Scaling Transformers to 1 billion tokens. The details they reveal about LongNet's capabilities open up possibilities we've never seen before in AI. In just the last few years, AI capabilities have advanced at an astonishing rate, and LongNet marks the next giant leap forward. So buckle up, because this technology could shape the future as we know it. What is LongNet? LongNet is a new type of transformer architecture created by researchers at Microsoft. As I'm sure many of you know, transformers have powered the recent explosion in large language models like GPT-3. But transformers have historically struggled with longer sequences due to quadratic complexity. LongNet solves this limitation using an attention mechanism called dilated attention. Dilated attention allows the model to exponentially expand its attentive field as distance grows between tokens. This reduces the complexity from quadratic to linear, meaning LongNet can process sequences nearly infinitely long. The Microsoft researchers implemented LongNet on sequences up to 1 billion tokens, a massive increase from the previous limit of around 1 million tokens. To put that in perspective, the entire English Wikipedia database is only around 3 billion words total. This means LongNet could theoretically process the full Wikipedia in a single training example. So how does LongNet accomplish this? Let's break it down. LongNet works by splitting the input sequence into segments and sparsifying each segment by selecting certain rows. This is done exponentially. Early segments are dense while later segments become increasingly sparse. Within each segment, dilated attention is applied to capture both local and global context. The segment outputs are then scattered and concatenated as the final output. This allows LongNet to greatly reduce the quadratic computation of standard attention, while still maintaining the ability to model long-range dependency. The Microsoft researchers also implemented multi-head dilated attention, with different heads attending to different offsets. This further improves modeling capability. By cleverly engineering attention in this way, LongNet achieves the best of both worlds. It handles long sequences while remaining performant on shorter lengths. So how good is LongNet's performance? In tests by the Microsoft researchers, LongNet achieved state-of-the-art results on language modeling benchmarks, outperforming baselines like sparse transformers. Importantly, it did this without losing any performance on shorter sequence lengths. The researchers found LongNet could model sequences from 1,000 to 1 billion tokens in length with strong results. When scaled up to larger model sizes, LongNet also followed the same power law relationship between compute and loss. This shows converting to dilated attention does not disrupt LongNet's ability to scale. The Microsoft researchers also verified LongNet could be trained in a distributed manner across GPUs and nodes. By parallelizing the sequence dimension, LongNet breaks constraints on computation and memory. This enabled the researchers to feasibly reach 1 billion tokens on modern hardware. The implications of LongNet are staggering. For the first time, AI systems can process unfathomable amounts of text as single training examples. This unlocks capabilities we can only speculate about. With an essentially unlimited context, LongNet could ingest the entirety of the internet as a single input. The insights it could gain from all human knowledge far surpass what any model today can achieve. Researchers are also excited about the potential for few-shot learning. An extremely long context could help models acquire new skills with minimal data, avoiding catastrophic forgetting. Some even theorize LongNet could lead to artificial general intelligence, as its capacity for reasoning and abstraction crosses a new threshold. LongNet represents an exciting step towards the future of AI. For the first time, natural language systems can operate with near-infinite context, unlocking amazing new capabilities. The prospect of models that can learn from the entirety of human knowledge is no longer science fiction. LongNet proves it is real and within reach. Of course, this technology raises important questions around safety and ethics that the research community must continue engaging deeply with. But the opportunities feel boundless. With LongNet pointing the way forward, the future of AI looks brighter than ever. The age of trillion parameter models is closer than we think. Let me know your thoughts on LongNet and its implications in the comments. And make sure to subscribe for more AI updates.